Hello. Again, a lot of things behind me. I'm going to take a little bit different approach for work energy and simple machines. I'm going to try to explain a little bit of the science before we begin doing some problems. The two major equations for energy, other than work equals force times distance, is the equation for potential energy, and that's mgh, okay? The equation for kinetic energy is 1/2 m mass v squared, 1/2 mv squared. This is the energy of position, the potential to do work. The energy of position, meaning height, really. It has to do with gravity, vertical distance. So let's say this is a hill here. Well, it's going to be this height, that height, times the mass times the gravity. Wait a second, hold it. MA is what? MG is the same as MA, right? MG is MA. MA is F, force. Force times distance, energy, there we go. Bingo, right there. This is the same thing. Believe it or not. Watch. This is mass, right? Kilograms. Kilogram times meter squared over velocity squared, right? Sorry. Right? Meter per second squared, right? Is meter squared per second squared. So this equals joule. That's how you define a joule, right? Kilogram meter squared per second squared. And this is actually force times distance, or Newton meters, or kilogram meter squared per second squared. Kilogram meter squared per second squared. Same thing as joule, right? So, work, kinetic energy, potential energy. Look at this again if you have to. It's all the same. Kilogram meter squared per second squared, okay? Now, the other thing I want to show you is the work theorem. The work energy theorem says that the work, I'm actually doing work, you have to actually do the work for it to be equal to the change in kinetic energy. That should make sense. In other words, the initial kinetic energy is going to be 0. Well, it may not be 0, but the change in kinetic energy. So the work equals delta KE, and that's going to be the final kinetic energy minus the initial kinetic energy. Delta final minus initial. It should be pretty simple. I know that kinetic energy is, the final would be 1/2 VF squared, 1/2 VF squared minus 1/2 MVI squared. Factor out the 1/2 M, you get 1/2 M times VF squared minus VI squared. Remember, it's difference of squares. That's very important. Very important. Difference of squares. It's not a binomial square. It is difference of squares. Very, 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 very important. Okay? So the change in kinetic energy is going to equal the work, and the work is going to be, the kinetic energy is going to be equal to 1/2 M quantity VF squared minus VI squared. Easy? Look at this video, especially the first two videos, a lot, because it really explains the first half of the chapter really well. Okay? Be right back.